Want better answers? Use better data. After years of struggling with old tools and practices, today's performance practitioners need the ability to optimize modern applications. They need the flexibility to use tools wherever they best fit, with seamless integration that makes every engineer more effective and valuable. That's where SOSTA comes in. SOSTA's load-testing flagship product, Cloud Test, delivers actionable intelligence that lets your performance team drill into live data to pinpoint any performance issues. Leading brands like Nordstrom, Best Buy, DirecTV, SAP, and MSN have all turned to SOSTA to simulate more realistic traffic for load and performance testing for web and mobile apps at any scale, anytime, from the cloud. Use predictive analytics to determine whether optimizing your site will provide enough ROI to justify any suggested changes. Cloud Test gives you complete load testing flexibility, from development to production. And let's talk about SOSTA's mPulse. It is the leading real user monitoring technology for better insight into your real users. mPulse allows you to accurately monitor your customer experience and take control of your business results. See how performance affects user behavior in real time so you can optimize in real time. The analytics capabilities found inside mPulse will astound even the most senior operations engineer and also leave your executives drooling. mPulse delivers the rich visualizations and real user data essential to their decisions about global application performance. SOSTA's Cloud Test and mPulse can instantly transform your application performance practices into a world-class operation. Learn more at www.sosta.com.
It's time for PerfBytes.
What the is PerfBytes? The fourth square meal of the day. Don't bogart the PerfBytes. Waffles. Microwave ready. Blah, blah, blah. Add nutritional value to your brain. It's time for PerfBytes with your hosts Mark Tomlinson, James Pulley, and Howard Chorney. PerfBytes.
Whatever.
Hey! It's time for PerfBytes with your hosts James and Howard and Mark. Here we are again. Hi, guys, how are you?
Great.
Just ducky.
Just ducky. It's the
And
fall.
It's raining out here in the Boston area, so there are quite a few ducks floating around.
Yeah, there's things to float in or on, as it were.
Mm-hmm.
That sounds right. It's raining actually here in Philadelphia. It's kind of nice, and it's almost, I guess it's hurricane season on the East Coast, right? Starting around September, October, isn't that right?
Yes, it is.
It starts a little bit early, but you get very few hurricanes early in the season. So once we get into fall, we tend to get more named storms.
Named storms. Sandy, because I remember when we started PerfBytes the day after Tropical Storm Sandy actually hit.
Yeah, I remember Sandy.
Yeah.
Yeah, and that storm named Sandy, too.
Oh, yeah, yeah.
Although there are no hurricanes planned for next week, I've already double-checked since I'll be taking my week on the beach with the lovely Mrs. Chorney and the Perf Hounds.
That sounds pretty awesome. Actually, speaking of where we're going to be in the next few weeks, we should actually top off the show like we did kind of last time with kind of stuff where we're going to be. So if people are just tuning in, they can come find us. First of all, the next time we're all going to be together is going to be at STPCon in Boston, in Framingham, right around from your house there.
Yes, sir.
Yeah, and we're going to be doing a live show. We haven't figured out exactly what night of the conference we're doing it, but we'll be there throughout the week. So give us a shout if you're going to be at STPCon. And if you haven't registered, you can still find, I may be able to get you a discount. You never know. Shoot me an email. But it's stpcon.com. You can register. That's going to be really fun.
It also gives you the opportunity to meet us all in person.
Exactly, and do a live show. James and I are going to be
participate.
Yeah, James and I are going to be down at Dynatrace, perform in Orlando. Sadly, Howard, will miss you there, but we will have seen you. Then I think we've got Test Bash in New York, and of course you guys can come to New York, although Test Bash is not, it's not performance specific at the same time.
But we can just have a real bash doing some testing.
I'm trying to make my schedule work out so I can come and say hi to the lovely Rosie Cherry.
I think she will be there. It's November 5th, 4th and 5th, I think. Around the same time in October, we've got Whopper. So the workshop on performance and reliability is out in Mountain View, California, with our friends from BlazeMeter. We like those guys, Ophir and Alana. It was Ophir's birthday recently. Did you know that?
I did not know that.
Yeah.
he doesn't tell us these things.
Well, it's one of those notifications from Skype. So I call it a Skype birthday. I don't know if it's a real birthday or not. Some people don't put their real birthday, on the Skype.
And Mark, both you and I, not just from an appearance perspective, but I believe both you and I did webinars today.
We just did webinars today, which was pretty awesome. So if you can't get enough of us, head on over to the rest of the PerfBytes library at perfbytes.com. You can listen to more of everything we do. The other one I want to mention was Alex Podelko, who always gives us a tip for CMG, the Computer Measurement Group. That's in San Antonio that first week of November. So if you're really looking to go a little deeper and get a little geeky and techie on everything you're doing around performance, CMG is a marvelous conference.
And two items on note of Alex. One, he will also be at STPCon.
That's right. He's presenting Thursday with us, I think.
Two, he does not realize this, but he's going to be assigned a portion of the Performance Manifesto. That's right. So, surprise, Alex.
Yes. He raised his hand. He was the most vociferous.
Yes.
Absolutely was.
Yes. Yeah.
And number three, when you go to San Antonio, do not attempt to use graffiti at the Alamo. Bad idea.
Yeah, you'll get arrested. Don't do that. All right. So we'll recap some of those at the end of the show. Anyway, today, guys, we are going to do a podcast in exactly 47 minutes and 33 seconds. And I know that it's going to be exactly that duration because everything I've done to estimate how much time we're spending yicking and yakking and gnawing on the subject, I've done the exact projection and extrapolated the time frame for the recording according to the estimations that were made from production. I know exactly it will be 47 minutes and 33 seconds.
You just used the E word, Mark.
Oh, what's the E word?
You extrapolated it.
Yeah, so the danger of today's topic is my crazy estimation on something as stupid as the duration of a PerfBytes episode, which is all over the map, is that probably the results of my calculation, my algorithm in my head, is skewed for some reason. And this is actually a huge black hole of trouble for the majority of performance testers on the world. And so we're going to talk today all about the common things that are skewing your results. Whether you knew about it or not, you might be skewing your results. We're going to talk about some more crazy or I think exotic things, James. You listed it?
Exactly. They're not from Italy and they're not built by, engine builder from Ferrari, but they are exotic.
Yeah, Luigi, the engine builder.
Somebody used to refer to my car as an exotic.
Well, maybe if it's an old piece of junk that's very rare.
No, it wasn't an old. It was a fine German touring machine.
Oh, well, you could call it an exotic if it's rare. But anyway, these exotics in part two we'll talk about are things that maybe you didn't even know could happen to you as a performance tester, but it's probably skewing your results. Then we'll wrap up with some tips on what to do about it. But to kick things off, maybe we should talk about first what it means to skew your results. Like, Howard, what in your definition, what does it mean if I skew my results, if somebody doesn't know what the word means?
If I skew my results, I'm actually giving myself false results. That would be my definition. I've gone out, I've tested, I've got a bunch of results. Now, they're not maybe I should call it more unreliable results because I wasn't really testing under the proper conditions. So therefore, I've got a bunch of false results. I've skewed my numbers, and I'm reporting up to upper management on bad data.
Right. And it comes back to a mathematical calculation where there is some kind of, I want to say an estimation or a calculation that has that thing called like a remainder or a rounding. So, James, arithmetically, skewing is a real problem. I mean, it's a real thing within the mathematical world, right?
Oh, yeah. I mean, there's this concept of significant figures. How far do you go, but beyond the decimal point before it really doesn't make a difference? I look at it on a comparison basis or a mechanical basis. I look for the number of deviations to production in our test environment and say, okay, if we have behavioral differences, if we have structural differences, if we have data differences, then we're going to skew our results. And what looks really good in the funhouse mirror of the skew, going to management, it's like, oh, look, you're 6 feet tall and incredibly attractive. Put a real mirror up there for the results.
And your arm is sticking out of your ear. How did that happen?
Exactly. But it looks good on you. Yeah.
Exactly.
Put a real mirror up there with the real results, and then it doesn't look so good.
Yeah.
And our objective, of course, as the last risk gate, is to mitigate any risk going into production.
Yeah. And the skew mathematically, to Howard's point, is that you may run a test and do some calculations statistically on your performance test results, come up with what you think is a real result, but actually you're way off. It's a false result. And
in Mark, we talked about the E word a little earlier, right?
Yeah.
Unless your algorithm is just spot on, you're never going to be able to predict your results, because I can test you won't be able to predict that exponential point of failure.
Yeah. Now, guys, go with me on this for a second. What if I told you, if you can't have a perfect result set, then what's the point of doing load testing anyway? This is all just crap. Is that a good statement? I mean, can I actually learn anything valuable even if my numbers are not perfect, quote unquote?
Absolutely, you can. It's called trending.
Okay.
You can look for trends. Your numbers may not be perfect, but if you're running your tests, you can look for specific trends. So things will be kind of close, and you can look for the peaks and valleys. So I'm always a big fan of trending.
Okay. What about absolutes, James? Like, is it always bad to make 40,000 calls to the database for one query?
Well, it certainly is. I look at...
No, Mark, I think we should do that every time.
Yeah, that's a very good question. Why, yes, Mark, that's really bad. You can actually find out quite a bit, even if you don't have the pure environment that's absolutely the right size and pure amount of data and all hardware matched. If you scale your load to the size of your environment, you can actually find some of those breakover points. Mm-hmm. You can find out architecturally if you have these huge inefficiencies, like those 40,000 calls to the database to satisfy that first user who comes onto the site, and things of that nature. So you can find structural issues, you can make recommendations. Now the question is, do you have time to fix them?
Right.
That's a whole different show on planning and time and everything else.
Well, if you did CI, you could fix them. You'd have time to fix them.
We'll get another completely new architecture in 3 hours. Yeah,
that's true. Well, CI may accelerate the writing of checks. There still could be technical debt that doesn't get paid.
I guess the point I was trying to make to James's statement is, don't wait to the last minute.
Totally, yeah. All right, so let's jump right in with the first one. Howard, if you want to kick us off, what's one of the first most common pitfalls that people run into?
Don't use think time or iteration pacing in their scripts.
You're kidding
They just cram it all into one and let it rip.
Really? So
what are you talking about, Howard? I don't understand why people wouldn't do that. I just don't believe you. Can you please explain now? Right now.
Yeah, I don't understand. You need to explain yourself. I mean, if I'm going to say the next sentence, then we're going to continue asking you a question about what this is, this thing called think time, because I have no idea.
Now, didn't that sound totally unnatural to you? Who types like that? Well, I guess people could type like that. But
yeah, especially if you're on a mobile device where you're just using your thumbs.
Exactly. So, we have to put a little think time in between transactions. And guess what? Transactions just don't pile on each other one after another, after another, after another. So for your set of transactions, it might be nice to put just a tad of pacing in between.
Yep. Now, one thing on think time that we have seen that skews the results, and let's say you run the test with no think time and you state, we're only using 1.3 gigabytes of heap in the app server. That's a beautiful thing. But the latch time for those transactions, the time that it takes to hold the session open, is really, really short. In reality, if it takes 2, 3, 4 seconds, or if it takes a minute or 2 minutes to complete the session, you're going to consume, in reality, more memory. So latch time on resources like RAM, heap, or actually blocking rows in the database on the back end, that's one of the ways that you'll skew the results.
Now, Mark, there is an architectural item that comes into play here. The client-server model is built upon a number of foundations, but one of those foundations is cooperative processing.
Right.
That is, the server does something really unique and interesting, and then it passes a message to the client, which also does some co-processing, unique and interesting stuff.
Mm-hmm.
In the case of what we do mostly these days, we have the server passing information to the client that runs some JavaScript, displays something, and then the organic computing unit reads it off the screen, processes it, makes a mouse movement, types something in, and then it comes back. But that interval in between those conversations of request and response, the release of those resources during that window can be used by other users. As we collapse that window associated with the use of resources from, say, 30 seconds to fill out a form to 15 to 10 to 5, we reduce that window of opportunity for other users, and eventually we destroy the integrity of the model.
Right.
So you collapse with no think time, no iteration pacing, and it becomes a non-predictor of what you're going to see in human behavior.
It's not representative of how the system resources would actually be used.
Yeah, and I think James made a really great point when he talked about the third processor, which was the carbon-based processor, who's not going to have all the answers
The warm-blooded,
right on top of their
carbon-based.
head, right? They may have to actually think about it, and guess what? We all think at different rates.
Oh, here's one for you. It asks you to get that security code off the back of your credit card before you complete the transaction. Oh, where did I put my credit card? Got to turn it around and look. Where's the?
Oh, I've memorized it.
I totally forgot.
James, the sad thing is I've memorized them all too.
Yeah. Anyway, for those who haven't,
Or you're on the help desk and they say, "What's the serial number of your PC?"
oh yeah, lift it off the desk, turn it around.
Exactly.
I don't know.
Hold on, I have to go underneath my desk to do something.
The other part of this, out of think time, most testing tools, calculate a pacing of some sort as well. And pacing is slightly different because it's dynamically derived from the actual response time of the transaction. So, for instance, with a arrival rate of one transaction every minute, if an actual transaction only takes 10 seconds, the pacing will say, little V user, you need to wait 50 seconds before you fire off the next request. The trick is to skewing your results on this one is that if you run without iteration pacing, then the next transaction fires off as soon as the system is available. So if the system under test starts to respond more slowly, then the arrival rate will also curve to become slower. So you're actually being very polite to the system under test, when in actuality, a constant linear arrival rate would pound the snot out of that system, the database or web server.
Unrealistically pound the snot out of it, Mark?
No, I think the arrival rate, if it's calculated from production, that you know this is how many people ramp up at 7 p.m. On a given site that you're working on or something, or you know what the real-world arrival rate would be, you'd like to kind of mimic that curve or that arrival rate trend exactly. That workload should be the same. So you don't want to be too kind to the system under test, because in actuality that's a false negative, meaning, oh, well, the system didn't really blow up that bad until XYZ. The truth is, it probably wouldn't scale that much at all. So iteration pacing is a big one that leads to misunderstanding the full scalability of the site.
So Mark, you touched on something which is another one of these very common pitfalls, which is if you know how people arrive, and in most cases you don't. There are some assumptions that are being made by server administrators based upon hits, not on business processes.
Right.
Something that's coming in from Omniture or Impulse that may not have everything, or you may not even be privy to it. It goes to a completely different group that you're not allowed to talk to because they're behind a program manager who's governing information going to and from them, that type of thing.
It doesn't like you. Yeah.
Yeah, so you're going to take two fingers, stick them in your mouth, put them up in the air, and you're going to assume how people arrive, and then you're going to have your workload match your assumptions.
Yeah. So really,
and you know what happens when you assume?
Nope.
You get barbecue.
Yeah, that's exactly what happens.
So the first tip is around think time and iteration pacing. This one, James, is about making some guesses, and you could call them guesstimates, or you could call them wild ass guess. That's but you assume something about reality, the workload, and this is where the marketing department didn't call you up and say, "Hey, testing guys, we're going to do a promotion with a spike test to 12x the normal volume. And so you just assume our spike test goes to 3x and it's fine. But the marketing department didn't call you and tell you what the hell's going to happen. Or you don't have friends in the ops department, like you point out, James, to really understand what's happening in production. And even if you have most awesome tools in the world, you could have a carbon-based, warm-blooded human being who doesn't really understand how the tools work and gives you the wrong calculations. So skewing your results is just sort of taking a guess at what the workload should be and not committing to learning how real users and the real traffic in production and the real user monitoring that you could get from production and pull that into your test design. And
no, I think this is where people this is where a lot of the real mistakes truly happen, Mark. Yeah. And talk about skewing results. I mean, if you're not workload modeling, that means I bet you dollars to donuts, people who don't have the information probably aren't even thinking about funneling.
Yeah.
So a way they're further skewing the results is, like every transaction is going to be treated equal. So heck, if I have 12,000 people hit the site, I'm going to have 12,000 people check out because all those 12,000 people are going to go to the site and then check out.
Yeah.
And now I've just crashed a certain set of servers, and that never would have crashed in real life.
Exactly right. So steps you can take around getting your workload right is really having a critical conversation with ops or actually observing the monitoring for yourself in operations, be it Splunk or be it Impulse or be it Dynatrace, whatever you're using to monitor production, jump in and take a look at what's really happening on the arrival rate.
And if you can't get that, I mean, this may sound crazy to some people, but, there are industry average statistics out there, so at least you'll have some sort of clue.
Yeah.
And that industry average may tell you that, on average, 100 people will hit your site and 6% of those people will buy. At least it's a number.
Yeah. All right, guys, we'll take a quick break for a word from our sponsor, and then we'll come right back.
Lightsquare.com is proud to be a sponsor of PerfBytes. Lightsquare.com is a unique offering for performance tuning as a service for web architectures. Lightsquare delivers tuning recommendations in under 72 hours without the typical investment in tools, license fees, or consultants where we do the work up front. With Lightsquare, you only pay based on the level of improvement. Find out more about Lightsquare's unique pricing model at www.litesquare.com/pricing.
So, James, what is, we've talked about think time, iteration pacing. We've talked about the crazy making up a workload for the fun of it. What's the next common thing that will skew someone's results?
Wow. Test data.
Yeah.
Having such a narrow set that essentially you're going to live in a 100% cached universe.
So that gets to randomization, parameterization of the load tool, as well as the actual quantity and characteristic of the test database itself.
Yeah, I mean, you get tossed test data and say, well, this is all you're going to get. Well, guess what, folks? That impacts our confidence in our test output.
Big time.
If we have just a small, narrow set of data and we have to use this same set of data all the time, I mean, we may have some sort of locking condition that's going to occur during the test that would not naturally occur in production because we have two users that have now hit the same record and are trying to update.
Yep.
Not to mention the fact that if you have a large amount of cache in your database and you have a small amount of data, it all winds up living in memory. So even if you have some really bad items in play, such as a table scan, you're not going to see really any performance impacts because memory is several orders of magnitude faster than disk.
Yeah, you might be able to load an entire partition into the buffer memory in the database. Yeah.
Hi, my name is Mr. Marketing Guy. Hi, Mr. Performance Test Guy. What confidence do you have in our new website that it's going to run beautifully?
100% confidence because we tested it in our database where we have 10 customer accounts set up.
Well, that just sounds great. I'm so glad we're going to do this massive launch right now.
How many customers, Mr. Marketing Guy, are going to show up on the website next Thursday?
I can answer that. That'll be 50,000.
Hold on. I'm licking my finger. I'm putting it up in the air. 372.
Okay, we can extrapolate from our 10 customers to 372 customers. What was it, James? You said 50,000?
I said 50,000.
Okay, so I'll just split the difference and say it's 12,483. That will be fine.
Let's go make money, guys.
There you go. And this is the ignorance. Now, there's a couple subtleties within data. Now, one, you need to be parameterizing and randomizing your test tool data to be like the real world. So the one gotcha here is some people will just give me an extract of all of the customer accounts and I'll just randomize them equally, uniformly in the test tool. If your data is partitioned, let's say you have some aging of customer data, where really, let's say in the business, there are some customers in there from 10 years ago that aren't even really active, and they might be marked as inactive, they might be marked as locked, they might be marked as punted or deleted. You keep an idea out there that there are some customers, usually maybe in the last 6 months, those are the most active customers, and they'll be queried on maybe the last couple of partitions. But if you randomize your test tool to use all the customer data back to all the history, you'll skew even though you'll be super randomized and parameterized, you might be equally skewed the wrong way. Like, we're querying partitions and scanning stuff from 10 years ago in production. Those people, some of them are dead. We don't even know who they are. They're not even customers anymore, but just because they're in the database. So be careful about aging of data and partitioning of data to make sure that you understand what are the most frequently accessed customers within a date range when you're doing something like parameterizing those accounts. All right, the next one, Howard.
One of my favorites, or not so much, running in a polluted test environment.
What is polluted? Give me an example of pollution.
Let me ask you a question. I actually have a nice little analogy here. After you eat food, you wash your plates, right?
Some people do, some people don't. Most people should, yes.
Well, let's hope that most people do, so they can eat off of a clean plate. After you finish testing in your environment, it's usually a good idea to scrub your environment, because there could be a lot of old results and old things hanging around that, if you don't clean them, guess what's going to happen? You're going to skew your test results because you're starting off with a dirty environment.
Because it's a dirty environment.
One of the things.
Yeah, how about this other thing where you're eating your dinner and you're trying to enjoy a nice chicken piccata, you know? And then while you're eating, somebody else comes in and puts a steak right on top of your chicken and starts eating the steak on top of your chicken, and you're trying to enjoy your chicken and measure the quality of your chicken, and somebody else starts eating a steak on the same plate.
So, Mark, we go back to this concept, and we've covered it a number of times, of this shared infrastructure, particularly with virtualization, where you're spinning up virtual machines, and you're on a host, and you can't control what the other virtual machines are doing on this shared host infrastructure, particularly if you have shared.
Can I just make one quick? Let's not confuse virtualization with using virtualized services.
No. This is machine level virtualization, and essentially your initial conditions are different every time on this shared infrastructure. Your in-test conditions are different every time, and so even if you have everything else perfect, your test-to-test variability is quite high.
Yeah.
Because of all these out of control elements that don't occur in production potentially, but are occurring in your test environment.
Yeah, and that's another type of pollution where in the middle of your test run, Mary kicks off a download or a build on the same server that's running in a VM that's on the same host. Suddenly all your CPU goes, how come everything's so slow?
And there's a developer who is downloading the latest version of Java, and another developer that's attempting to watch some adult entertainment from 3 continents away.
Or football. Could be watching football.
We're talking developers here.
Oh, sorry. That's right. They're watching old reruns of Firefly.
Okay, I'll go with that one.
That one works.
Oh, somebody's decided to do a database refresh right in the middle of your test.
Oh, yeah.
Yeah. So polluted environment will skew your test results because, again, as you point out, James, repeatability of the test or variability from run 1 to run 2 to run 3 is you can't control for it. You can't estimate. So if you publish results that are absolutely the final results and then you ran the test the next day, it would be totally different. That's totally skewing your results. I love the pollution of the test environment. And there are other examples of polluting the test environment like we've talked about on other shows. What's the last one is probably really common because we get questions about this all the time.
So you want to take us through this one, Mark?
Sure. If your test environment is, let's say, smaller than production, and the majority of people in the testing world, in the dev world and testing world, the ops guys and the production guys are like, well, we run in the cloud. We have thousands of nodes. And your little test lab only has 2 nodes because, well, we don't have the money for you little testers. We don't have the money. And developers are like, we don't need thousands of nodes because I don't do measurements for performance at scale. So the big problem that's going to skew your result is, let's say you run on 2 machines in the test lab, and you can run 2 transactions per second. And in reality, you're going to be running in production on 150 machines at thousands of transactions per second.
Which, by the way, if you can get it down to 2, you'll save a lot of money.
Absolutely.
There's a lot of stupid arguments that say this is okay, but the truth is, the problem with skewing the results is extrapolation, the E word, Howard, as you brought up.
I was just thinking that, Mark, as you were talking.
The reason extrapolation is evil is because the more you extrapolate, the more that trend line that is an imaginary trend line, I'll call it imaginary, Howard, just because it's actually based more in fictitious calculation than it is on an actual trend of data that is hard, actual, factual data.
Absolutely.
Yeah, so the idea that the further you reach 10x, 100x, 1,000x, 2 things. One, your mathematics is going to be off. The higher you go, the more you extrapolate, the more your mathematics, no matter how wonderful you come up with a model, it falls apart. The second thing is, even human beings in your management chain that are mostly technical people, but probably not anymore because they're managers, as soon as they hear you say something like, we extrapolated by 30x, they aren't going to believe you as a tester. This is a human being. Even my dentist would be like, you 30x, you extrapolated? That sounds stupid. I would never do that.
You know what's even scarier, Mark?
What?
People who just accept that.
Well, they if you try to blow them over with confidence, I am an experienced tester with N number of years, and I wrote a book, and I am with this big brand name logo consulting firm. If you try to blow them over, then they will trust you. But if you know better, if you know you're extrapolating by 100x, and your calculations, even in a perfect world, are going to be way off, you are doing a huge disservice to your customer. So don't do this.
Yeah, and I think you should disclose these items right up front. Said, here's what I know is bad about this test result, which impacts the risk of deployment. And the natural question is, well, how can we address that going forward? Well, you can get me a better environment. You can get me better data. You can get me better
more
information
machines, more
on the load model. You can stop the functional testers from changing my data during the test.
I don't know about you guys, but I always put caveats in my results if I know they're going to be caveats.
Well, that's the huge tip for sure. So if you're testing at scale, there are some techniques that can help, but overall, your results, the more you extrapolate, and I try to limit most customers at about 10x. Like anytime they extrapolate more than 10x, pretty much every human being on the planet will not believe that your results are accurate. So try to keep it at 10x or less. Because if I went to you, Howard, and said, 2 nodes ran 100 transactions per second, we think if we go to 4 nodes, it'll go to 200 transactions per second. Sounds kind of reasonable, right? It's like, it's not out of the ballpark. It's pretty believable. Yeah, 2 nodes this, 4 nodes that. But it's only a 2x extrapolation. That's a good, trustable guess. But Howard, if I said 2 nodes will give me 100 transactions per second, that means 12,000 nodes will give me 1,000,000 transactions per second.
Mark, I'd have to question that.
Yeah, you're going to hit some other resource item that you haven't been tracking in your assumptive model that you're going to run out.
Sure. How about the load balancer? How about infrastructure like the telco switch right outside the data center?
I wasn't even going to say stuff like that, but because I was just a given. I was just having fun on the extrapolation part of it. I was going to ask you what you were drinking that evening also when you made those calculations.
Exactly right. So that's really what happens when you try to do this, why extrapolation is evil. It's because it's inherent in any mathematical virtual calculation into a forecast, if you call it a forecast properly, that there's going to be variability in the model. And yeah, one of our big tips is if you know you're extrapolating more than 10x, you need to put a big asterisk at the top of the report that says, FYI, these results are the result of the following configuration limitations. We are limited to only so much hardware, limited to only so much data. And that's a good tip. Before we go into more exotic terms, should we take a little break for a public service announcement?
Sure.
Mark, have you ever been let down by the quality of a performance testing contractor or service provider who claim to know more about system performance than they did in reality?
Yes, James. Perhaps it's time to start working proactively with our friends in the Services Procurement Department and help them to learn about performance testing and engineering resources.
I know what you mean, Mark. Certifications are not a surefire method of screening candidates.
And you know, generally, there's no school or academic accreditation for performance skill.
Experience must be backed up by references and recommendations from former employers.
Procurement people should remember that being a general tester is not a qualification for doing performance work. So please don't just reassign those guys from QA.
Always remember John Ruskin's common law of business balance, which prohibits paying a little and getting a lot. PerfBytes encourages you to develop a positive relationship with your brothers and sisters in the Services Procurement Department because we know that they know less than you know about the resources you need to be successful in performance.
All right, so now if the audience is still with us, they still want to hear more of what experts like the three of us have run into in the strange department of weird stuff that skewed our results that maybe we weren't thinking about. So, James, you want to kick us off here?
This is one I love. Rendezvous or simultaneity.
You have to say that in like a French accent.
Rendezvous.
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 Mais oui.
And or simultaneity. That is bringing a whole bunch of users together and doing the same thing at the same time.
Yes.
This gets back once again to the client-server model. Humans are chaotic instruments. We are not governed by a clock tick to do something. If you have 1,000 users that need to do the exact same thing and get the exact same information at the same time, have you ever looked at a stock ticker?
Right.
Yeah, it's broadcast out, very efficient, doesn't require a whole lot of resources to handle it. But we see this commonly in tests. It's like, well, I only have 150 users and I need to represent 500. Well, you know what? Rendezvous is not the way to do it. And if you insist that you have to have rendezvous involved, then call them up in Memphis, Tennessee, and have them overnight a whole bunch of barbecue to you.
Yes.
And that's how you should involve rendezvous in your performance testing effort.
And then you know what? You can all eat barbecue while you're all sitting with your finger over the space bar, and you can say 1, 2, 3, click the space bar.
Yeah. So this is very common, and it is also a common marker on resumes. If you see resumes which are littered with rendezvous,
yeah,
you know that is a person that doesn't understand human behavior.
Yeah, I think it's still good to note that there are certain kinds of tests where you want to test for, let's say, record blocking, race conditions, anything that is about intentional concurrency, very technical tests, I think, James, where it's appropriate.
Very, very technical, highly engineered, small numbers, not 100 people doing a rendezvous at any given time.
That's
You're
right.
talking, maybe you are a major credit card provider and you are trying to test for a condition that occurs once or twice a year, and you're probably looking at maybe 5 to 7 users in the same section of code at the same time.
Yeah, so it's still valid to do that, but in only certain types of tests. I could see a spike test maybe with a 10% rendezvous during that spike ramp up, just to kind of give a little bit more concurrency. but never, 100% of my 1,000-user load are rendezvousing and bam.
Yeah, I mean, the last time I used Rendezvous really, really heavily, I was attempting a spot sale test, and we ramped everyone up to the Rendezvous, and then right after the Rendezvous, we had a sleep of up to 10 seconds to release all of these users within a 10-second window.
There you go, yeah. But now, how does something like this skew your result? That's the real thing. Like if you're overly blocking, you have incorrect.
So what you're having with this, it's very similar to getting rid of think time, because you're eliminating this chaotic arrival and departure. But not only that, but you're creating this concentration at this one point of code in the system. And most code is not designed from the outset to be highly multi-threaded.
Yeah, not nowadays.
Yeah.
Anyway, yeah.
And as a result, what you're going to have is you're going to have a lock or a semaphore-style lock, which is going to impact one or, at that +1 or +2 or +3 condition when you add those users at the same time. You're going to get an unnatural locking condition that would not occur in production.
Yeah. So you might end up with a false positive, meaning the result actually shows that it won't scale because you're just hammering it concurrency-wise, simultaneous-wise. But in reality, in production, there's more of a give and take during that. It's still maybe a spike, concurrency, but it's never as dramatic as a test tool doing a rendezvous, which is like within the same microsecond.
And like a constant pounding, too. You're not going to get that in production.
Yeah, exactly. So that's good. So overuse or misuse of a rendezvous could lead you there. What's the next one here, Howard?
Starting cold.
I love this.
Yeah, it's one of my favorite things. So basically what you're doing is, I'm going to run a test. I'm going to have 10,000 users, and I'm just going to fire up the 10,000 users right away doing everything we can do because, God, we don't need to do any cache warm-up or anything like that. The system should respond just to like that. No problem at all, right? Right, Mark? Right, James?
Just bam.
Just bam.
Don't ease us into it. Don't take us out for a movie, do some dancing, maybe a little cocktail.
Warm up your caches. So look, here's another starting cold thing, how it's going to skew your results, right? You may elongate your transaction response times because you're going to get things for the first time.
Well, that and there are resources that do spin up on the fly. So if you min and max, say, number of threads or memory or something, that physical allocation to create a thread, to allocate physical memory for the thread, if you're like, you're going to count within your transaction time the extra, let's say, 250 milliseconds, 300 milliseconds just to create the thread, another, let's say, 100 milliseconds to give it the memory. Even if you're in a virtual platform, you're still going to spend a tenth of a second. And then you multiply that times thousands of users. You're right. Don't just start from cold. Maybe run a warm-up test, like a smoke test, for a few minutes, then stop it, and then run your actual
So we can
load.
have an analogy from our carbon-based units here. It's like, do you just go out and start running, or do you stretch a little before you go jog 5 miles?
Or maybe you start by just running to the mailbox and back, and then maybe to the end of the street and back. But you don't just go out and ride a bicycle for 106 miles like I did.
Yeah, there's a great physical analogy here beyond the ones you've already brought up. I call it the teetotaler vodka analogy.
Yes.
James, do tell.
So you get a teetotaler, a bottle of vodka, and you combine Bluetooth style from
Yes.
just tip it up and all the way down the hatch. Well, you're going to get what you might call system shock.
System shock.
By doing that. And the system's not going to be able to respond effectively or efficiently to the increased load.
Yeah.
On the other hand, you get the same teetotaler, a thimble, and a bottle of vodka, and you combine a thimbleful at a time. The system is actually able to warm up and cope with this ever-increasing load on the system.
That's right. And in production, you have to understand, if you, let's say you have an elastic infrastructure, even with load balancing, when you spin up a new node, yeah, that new node is cold, so to speak, but the load balancer, some of the load balancer algorithms now don't give just 100% traffic, bam, to that node. It slowly trickles some traffic onto it before it actually starts bringing it up into the full balance of the mix.
Now, is that not intelligent load balancing?
Isn't that smart load balancing?
or if you're in the cloud and you have loose coupling through queues, as the new node comes up, it can retrieve its first element from the queue. It can process it. It can essentially compile all the code for compile all the fly. It can warm itself up, reinsert the result back in the queue, get another one, and it can speed up on a dynamic basis.
Yeah, very smart. Now, the next one, which is kind of the opposite of not having a ramp up, is we're calling no ramp down. And James, you have a different analogy for this one.
Yeah, so this one, the analogy is the heroin addict.
I see I sense a theme here, Howard.
Yes, yeah. So you take a heroin addict and
are you having a bad week, James?
Yeah. Drugs and alcohol week here.
They're hooked on the smack, and then you take it away from them.
Take it away from them.
What? Yeah, what's going to happen?
They're going to go into withdrawals.
They're going to go into withdrawals. They're also going to go into system shock because their system is used to that. So if we have 100% of the load, all of a sudden we cut it off. Let's say we have a 10,000 user test. We just cut it. We orphan all the sessions all throughout the system, all the memory that's there, anything that a user would naturally clean up, and as opposed to leaving it open. And the system is actually going to be in a fairly unstable state at this point.
So if you're taking measurements or samples of response time and performance and metrics during that denouement, we'll say, it's likely that the system is reaping back resources, maybe returning physical memory back into the system, that the network itself is sort of getting back to, if it's got an expandable or dynamic window size, maybe the window size is shrinking back down. There's overhead with the compaction or the contraction, right?
Yeah, so you want to see actually how the system recovers, how those resources get released as you ramp down.
Yeah, exactly.
On a more ginger basis.
Yeah.
And that also tells you if there's resources that remain locked and never get released, you've got a leak someplace.
That's true. Howard, you're going to say.
Yeah, there could be a spiral effect here too, right? So let's say you have to do let's say you're trying to do a lot of test runs in a day. So guess what you've just done? You've just created a polluted environment.
That's
so
true.
Your next run is just going to be garbage right off the bat.
Yeah. So we've got the teetotaler vodka we got alcohol poisoning and heroin withdrawal. All this at DTs.
The death spiral of cutoff testing.
Well, I can tell you, people don't forget those analogies.
True. Now, they also don't forget radio plays where we all became robots, because the next tip we have on skewing your results is that much like the workload being inaccurate, you just have a complete blind spot to some kind of load that you're not including in your test. And that could be what, Howard?
Bots, yeah.
They're gonna get you.
Bots.
We love episode 63 where we talked about bots, but the truth is there's plenty of other traffic. You could have, let's say, online dynamic traffic that's happening, but there's a trickle feed from the accounting department, or there's a batch job that runs, or there's those partners that run on some other part of the site, but did we know there was a database link, DB link? Oh, I hate DB links. DB link coming from that database to your database, and that sucks resources. So,
I mean, imagine if you're a cell phone provider and you have your direct sales outlet, and then you have partners like at Best Buy or something like that in kiosks, or Walmart, and they're coming in and you're not accounting for their load.
Yeah. So if you've tested with your blinders on, and again, you've screwed up that workload, it'll skew your results because you'll give an estimation for the primary load you tested, but you didn't include the 20% for the bots, the 30% for the partners, and another 10% for the things that no one even thought about.
Isn't that why you're supposed to put a buffer over on your load?
Well, you can. I like to segment it in phases where I'll do smaller tests that are very specific.
Absolutely, but you're still, at the end of the day, you're still ramping up to it. You're still going to get yourself into that. It's like, all right, this is what my 100% is. I'm going to see what my 120%
Well,
is.
I mean, traditionally, I like to go 18 months out because you were looking at more waterfall development. Now that we have more agile development, it's hard to tell how far over we push it.
Yeah. I agree with that. Now, there's a couple other tips here that will screw up your results from the idea of testing in production. I think these next ones are definitely outside the firewall. So, Howard, I want to ask you, the biggest one we get after on News of the Damned is the CDN. But tell us a little bit about how not working with a CDN provider during a test skews the results.
So most CDN providers, they give you X amount of bandwidth.
Okay.
All right. So if you're exceeding that bandwidth at one edge server, they're going to start to throttle you. So think about this. Think you are using, and this just isn't in production either.
Yeah.
There are a lot of times you can use X-tier external load generators hitting a test environment. We've done it in several companies, right? But the point is, if you're going to be going over your allotted bandwidth from a CDN provider, they're going to throttle you. So what's going to happen is you're going to get skewed results because you're going to be throttled.
Yeah, and especially if you had a game day event where you would call them up and say, "Guys, open the floodgates," they wouldn't throttle you because they know that they're your partner, right? But during the test, if you don't call them, you don't coordinate with them, next thing you know, they're treating you like a DDoS, and they're shutting you down.
Mm-hmm.
All right, so that's good. So it will make transactions look longer, make it look like you can't handle the load. I don't know, maybe some CDN providers, the smaller ones, the more simplistic ones, any load that they can handle, they just roll over to Origin, and so you would end up putting too much load on Origin. Have you guys ever heard of that?
I have not heard of that condition. I've heard more of the throttling condition.
Yeah.
The challenge that we have is most of the time our load generators are in a finite number of places. So we're hitting a finite number of edge servers for this CDN provider. And we might hit as few as one. And they have to reserve bandwidth for their other customers.
Oh, I'm going to throw one out here for you. Exactly on that topic, James, is you can skew your results if you don't include IP spoofing on your load generator.
And certainly if your load balancer is IP-based, you're absolutely right.
Mm-hmm.
I think that's tool dependent.
It is tool dependent. Some tools can do this. Some tools don't do it well. But it's, if you're in a highly load balanced world that's IP based, you could end up putting all the load on one node and not know it. Especially for those of you, those of you who aren't monitoring the system under test, shame on you.
And then you get what you deserve.
Yeah, that's not good at all. Now, the last one here, Howard, I also wanted to bring to you, just talking about real-world network conditions, also trying to figure out how to mimic this either in the lab or during production tests.
Yep. People don't take into account that latency is a huge factor. You don't get from point A to point B for free, so there's always going to be latency. And yes, your CDN may minimize some of that latency, but anything going back to origin is going to bypass your edge server.
Yep.
So guess what? That transaction is not going to be instantaneous. And if you're not mimicking that condition in the lab, you're definitely going to get false results on what your true transaction response times are going to be.
Yeah.
And that especially comes into play for mobile, Howard, because they have longer latch time all the way from your CDN through to your origin when they need to touch things.
Another thing too is if you're in a lab or even in production and you just can't hit your credit card company, and well, probably not in production so much, but you're in a lab and you want to replicate what happens when you're doing a call out to your credit card company.
Sure, some third party.
Use a service virtualization tool, and guess what?
Yep.
I guarantee you that call out to the credit card company is not instantaneous. Again, latency is going to have to come into play there.
Yeah, I got to say, some of the customers I work with, they've built brilliant homemade little simulators, and they did two things. They forgot to put a thread pool in front of it so it would scale, and secondarily, they forgot to inject latency and random latency. That'd be nice. Give it a min and a max so that I could do some randomness. That would be fine.
Because it's never going to be the same every single transaction.
Yeah, how hard is it to code a single sleep statement on a variable? Come on. So, James, you brought up one last one here, which is in real time. We're being very agile right now. So you're offering up a change to the plan. What did you just write?
One load generator.
Isn't that where you need your IP spoofing?
Well, not necessarily. What happens on one load generator is that you can't tell quite often if you have a load generator induced problem in your response times versus an application induced problem. You have no control element.
So could we generalize that more into just not properly configuring your load generators?
Yeah, it seems like so many people want to run their load on their controller. And this is independent of
I
tool.
mean, it's just that's a matter of calibration,
let's-
right? I think that would even be a better way to say it. People aren't calibrating
that's right.
their load generators properly.
Yeah, so let's just say rule of thumb: if you don't have at least 3, ask questions. Ask lots of questions.
And I think it can skew the results in a way that says, wow, things are really slow. When actually, if you opened up a browser on a separate machine, boom, the site is snappy because you've overloaded your one load generator, right?
Yeah.
Exactly. And so many of the performance testing vendors on the market, they do not mark their code as non-swappable.
That's right.
So they will let you have a whole lot more load generators that can physically fit on the box into resources. And they will just start swapping out virtual users as they're idle and calling them back for disk. All of that slows your virtual user down tremendously. If you have a control element as a machine which only has 1 or 2 virtual users on it, you can actually watch that during the test.
Yeah, you can see the overloaded load generator gets slower and slower and slower, while the canary, as I like to call it, canary in the coal mine, is happy and healthy. So yeah, that's a false result. These are pretty good. Exactly. So let's wrap things up a little bit with sort of our final tips for folks out there. The first thing that I'll throw out there is that no matter what it is you've done in your load testing, chances are of the 14 or 27 things we just listed in this podcast, chances are you've done something to bias or skew the mathematics of your test results. So figure out what it is that's a limitation or that you see as potentially skewing your results, and be sure to communicate any of those items at the top of your test result. Put a report on there with an asterisk that says, by the way, we're testing at 1/10 the scale of production, or we only tested with 1 load generator and it was overloaded. So I know it's not popular. It probably doesn't make you sound like you know what you're doing, but the truth is you're pointing the finger usually at the test conditions, the resources you have, the other engineers or the customer around you that says, well, you have to do load testing on this one machine. You're pointing out limitations for the whole team, not just you. And you owe it to your customer, internally or externally, to be honest and give the full truth. And so that's my advice, is to make sure, hey, list it in the report. These are the limitations of these results, and here's why.
And it's better that you do that as a tester than to give your results to someone who doesn't like them and then have them pull that out and use it like an aluminum baseball bat to beat you to death.
Own up to it. Be the one that contributes to the truth versus somebody who gets blamed later. You don't want to be that guy.
I even think you can take this a step further, right? If you know this is what your conditions are going to be, state it in your test plan above so you have a really nice consistent message all the way through. Sure. It's like, hey, I recommend that we tested with XYZ. You're only giving me X. These are the results you're going to get. So there will be no surprise in this report.
Yeah. So Howard, what other tips do you have for folks in summary here?
Get sign off from the business for business transactional load. And not only that, for business transactions. So don't just make it up. It's like, I think a customer will do this, that, and the other thing. Go get some confirmation and sign off from your business partners.
That sounds good. Don't just make up a workload. And if your business people aren't talking to the ops people, you might be the facilitator. Bring them together.
The go-between.
Yes, you might be
the ambassador of good performance will.
That's right. Be a facilitator of quality. James, what are your final tips here?
Yeah. So 2 things. One, if you need to educate the business, try to pin everything to objective data. Go to the logs, go to database tables, go to actual sales if you're an e-commerce site.
Yep.
But pin what you're doing to an objective reference that they accept and they understand.
Yeah.
Because that'll make your life easier. And lastly, there is a website I've got on my website, jamespulley.com/handicap. There's an actual model there for building a confidence interval on a test from like 0 to 1,000.
Yeah.
And a lot of the items that we covered as a part of this show are built into that model. I don't expect you to take it verbatim, but take it as an example of what you can do to provide greater insight into the quality of your test to your customers.
Yeah, and improve what you're doing based on what you learn from using that. Thank you for putting that out there, James. I only vaguely recall that from many years ago.
And
James,
with contributions from Alex Podelko as well.
Oh, that's right. There we go. Awesome. It's a beautiful, beautiful episode. Well, PerfBytes listeners, we're glad you've listened again to the estimated content of this show today, although you should be aware that the scale of the recording environment was much smaller than the distribution of the actual podcast within about 65% of the target load objectives. We still thank you for listening.
As always, thank you to the lovely Mrs. Chorney, and of course, thanks to our listening audience. Without you, we are just the trio of lost souls. Thanks again, and please tell your friends and colleagues about the show.
Mom, thank you for listening, and have a great time at the beach this weekend.
As always, I will say thanks to the sexy Irish voice of PerfBytes, and special thanks to our supporting sponsor, Sosta, for their support of the PerfBytes show, and you, the PerfBytes community.
Today's show is powered by supremely tasty and energy-concentrated sugary kids cereals.
All the contents of this PerfBytes episode is 100% copyrighted and protected by Tony the Tiger. Dare to infringe on this copyright, and Tony will slice you up and use you as a banana in his frosted flakes. They're great!
For more information about PerfBytes, please visit the show's website at www.perfbytes.com or follow us on the Twitter, the Tumblr, the Facebook. And of course, you can always subscribe and listen to the PerfBytes podcast on iTunes, iHeartRadio, TuneIn Radio, Stitcher, and testingpodcast.com. Just open your favorite listening app and search for PerfBytes. Click the subscribe button and you're good to go. Hey, while you're at it, why not give us a review on iTunes? That would be nice. And you might not know this, but you can also send us an email at ask@perfbytes.com or even leave us a voicemail at 77-LOAD-PERF. That's right, 775-623-7373.
So, PerfByters, keep those cards and letters coming. And if you want, just send a carrier pigeon. We'll send them on back.
The PerfBytes show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, Test Bash and the Ministry of Testing, the Computer Measurement Group, the Workshop on Performance and Reliability, and of course, the Software Test Professionals community of software testers. We hope to see you at the next S2PCon conference in October in Boston, near Howard's house. Join us there for a live PerfBytes episode, great performance testing workshops, training, of course, single malt scotches, and someone will win a pair of PerfBytes shoes.
Yes, the coveted PerfBytes high tops. Howard, we need to get you a pair of those.
I know, we've been saying that for months.
All right, we'll get it worked out. Thanks for listening, everyone, and we will talk to you on the next PerfBytes. So long.
Ride 'em, jackalope.